Hey everyone, it is Mr. Vargas here looking to help out Math 8 with homework assignment 5.1, page 375 all. We are now in the study of geometry, which is pretty cool. We get to study shapes and lines and angles and all that kind of fun stuff. I'm excited to do geometry with you guys, and we also get to see how algebra fits within geometry. But first, before we get started on 5.1, let's go over some very important vocabulary. So here is kind of a standard picture that you guys are going to see, maybe slightly different in different scenarios, but in this case we've got parallel lines here, represented by the green. So we need to know what parallel lines are. They never touch, they go on forever in both directions, and they never cross. This line right here down the middle is what is called a transversal. And transversals, spelled here, cut through both parallel lines. And when that happens, we get some angles popping up. And I've actually numbered them here. We've got 1, 2, 3, 4, 5, 6, 7, 8. And those angles have special types of names. In particular, the exterior angles are all of the angles on the outside. So if you think of this section right here as the inside, in between your two parallel lines, then the area outside of your parallel lines, that's the exterior. So here 1 and 2 are exterior, 7 and 8 are exterior. Interior angles would be the stuff inside your parallel lines, so we've got angle 3, angle 4, angle 5, and angle 6 are on the inside. Now that we know that, we can go even further and break it down into angle pairs. In angle pairs, there are also some special types. Alternate interior angles just means that you're working on the inside and you're looking on the opposite alternate. So if you alternate something, that means you're switching it. So here, angle 3 and angle 5 are both on the inside and they're on opposite sides of the transversal. So we call those alternate interior, and these are always equal in value. Same thing with angle 4 and 6. These are alternate interior angle pairs. These are always equal in value. And then we can do the same thing with the alternate exterior angles, spelled here. Angle 1 and 7 are alternate exterior angle pair, and angle 2 and angle 8 are a pair. Let's go back to my picture here. So 1 and then 7 would be alternate exterior on the outside. 2 and 8 would be alternate exterior angles, and those are always the same size. Last but not least, we have what's called corresponding angles, and these just have to do with matching angles in terms of their position on both sides of where the transversal meets or crosses through your parallel line. So if I look back up here, angle 1, its corresponding angles, so you'd look and find which angle is in that same position on the other side, and that's angle 5, both in the upper left hand corner. 2 and 6 would be corresponding angles because they're both in the upper right hand corner. 3 and 7 would be corresponding angle pairs, and then 4 and 8 would be your last corresponding angles. So with that said, let's get into some of the homework problems. Alright, problem number 1 gives us this picture and asks us to classify each pair of angles as alternate interior, alternate exterior, or corresponding. So whenever you see this little symbol right here, kind of looks like a crooked L, I guess, that's called angle. This means, literally translate into angle. Okay, so we would read this as angle 2 and angle 4 are, well, if we go up to our picture, angle 2 and angle 4 are in the same position on opposite sides, so these would be called corresponding angles. Alright, let's check out number 2. Here they ask us, what about angle 4 and 5? So angle 4 and angle 5 are, let's see, angle 4 is right here, and angle 5 is right here. They're on opposite sides of the transversal, and they're both on the outside. So these would be called exterior, alternate exterior angles. Alternate interior angles. Okay, and that's it for number 2. Let's go ahead and jump to the next problem. Alright, problem 3 gives us a flag. And all that, extra stuff, the flag stuff is just kind of fancy decoration. But what we really care about are the lines that are going through this flag. So I've just kind of redrawn that here. We've got our angled numbers, 1, 2, 3, 4, 5, 6, 7, 8. And then they tell us that angle 1 has a measure of 150 degrees. And then they ask us, okay, if angle 1 is 150, what is the value of angle 4 and angle 7? So angle 4 is right here. Whoops. Angle 4 and angle 7. So with this, we can quickly figure out what the other angles are, 4 and 7, just based on what we know about angles. Angle 1 and angle 4 form a straight line. And what that means is, when two angles form a line, they have a sum of 180 degrees. So they have a sum of 180. So if I know angle 1 plus angle 4 has to equal 180, we can use some simple substitution to figure out what angle 4 is really quickly. Well, angle 1 they told us was 150 plus angle 4 is equal to 180. In order to solve for angle 4, we can subtract 150 on both sides. Okay, and that just means that angle 4 is equal to just 30 degrees. 180 minus 150 is 30. So angle 4 equals 30. And then you know that angle 7 and angle 1 are both corresponding angles. They're in the same position in different sections. So once again, Alright, so angle 1 and angle 7 are in the same position in different sections. So these are called corresponding angles, and corresponding angles are equal. So angle 7 also has to be 150 degrees. So in your statement you can write angle 7 is 150 degrees because it is part of a corresponding angle pair with angle, what was that, 1? Yeah, 1. With angle 1 and corresponding angles are what we call congruent. And in math, the word congruent just means the same measure. So there you go, that's a good justification for that answer. Alright, really quickly, let's jump down to number 7, part A and B. I'll let you guys try 4 through 6 on your own. But number 7, part A says, the parallel lines at the right are cut by a transversal, find the value of x. So we've got two parallel lines going like this. Okay, and then they're cut by a transversal like that. And then they give you angle 1 is right here, and angle 2 is right here. And then they tell you angle 1 and angle 2 are corresponding angles, which they are. They're in the same position in different sections, same position, upper right hand corner. And the measure of angle 1 is equal to 45. So since they're corresponding and corresponding angles are the same, or they're congruent, This one also has to equal 45 degrees. So then they ask you, okay, find the value of x in this statement. Measure of angle 2 is equal to x plus 25 degrees. So for this one, we need to figure out pretty much what the value of x is. Well, I know the measure of angle 2 is just 45, so I can replace that with 45 degrees. And that's going to be equal to x plus 25 degrees. Going back to our algebra skills, what's bothering my x? How do I get my x alone? We can do our mirror thing and then just do opposite operations. Subtract 25 on this side, subtract 25 on that side, and x comes down all by himself. He's happy, and 45 minus 25 is just 20 degrees. So this would be your answer, x equals 20 degrees. Alright, that's it for this video. Good luck on the rest of the assignment, and we'll see you in class.